to my inquiry project, which sought to answer the question, how does an explicit teaching of science practices impact student self-efficacy? So today we'll be going through all of these different parts of my project. I want to highlight that for the interventions that I describe and the results that I describe, I won't be going through all of these in particular in depth, but know that if you have any additional questions, please feel free to ask me in the future. For some context, I conducted this investigation in my 2 classes that I taught at Hopkins School in New Haven, Connecticut. There were 12 students per class, and they were 8th graders, so they were 13 to 14 years old, and this was an Earth and Climate Science class. For some background on the story of my question, I began to want to incorporate more investigative learning and more practicing of science in a flipped classroom model last year. And after thinking more about this, I consulted some student feedback, and students often reported that they wanted more labs and more hands-on activities. However, there was a smaller portion of students that reported that they would like more notes and more traditional science learning. So after thinking about this and some research that I had read about hands-on learning and questioning and retrieval practices, I decided that flipping the classroom would be a good model for my classroom, which students seemed to really enjoy. The one roadblock that we ran into was that students were often unsure of how what they were doing in class applied back to assessments that they were taking. So they didn't value the application of their knowledge as much as they valued something that could be memorized and then reproduced on an assessment. So this led me to think, where's the disconnect here? Are students unsure of the quality of their investigations so that they don't know if they're finding the right answer? And then would making students more aware of and more comfortable with and better at using science practices, better able to conduct these investigations and then trust their results? So this is how I arrived at my question of how does explicit teaching of science practices impact student self-efficacy in science? Largely, this is a question, though, of what is the appropriate amount of scaffolding necessary to successfully use inquiry-based learning in my class. For a definition for self-efficacy, I used people's beliefs about their capabilities to produce effects, and I looked at this in 2 applications. Number 1, students' willingness to and confidence in undertaking investigations, and then number 2, confidence in seeing those findings as course content. For a definition for practices, I used NGSS practices, which are laid out in this format in their 3-dimensional model. In addition to this question of asking, or this practice of asking questions and inviting problems, there are also 7 other practices that are named. For my first intervention, I created content videos specifically about individual practices, which made practice teaching more apparent to students by making it seem more like content. This also freed up some time in class for further investigations. Number 2, I asked for students to have more metacognition in practice-based tasks. So during and after labs, we would have discussions about why they're choosing to do certain things with their labs, if they're conducting their own experiment, if they're designing their own experimental procedure. There were questions in lab sheets that asked them to explain why they were doing what they're doing, what choices they're making. Is the data you're collecting qualitative or quantitative? How are you analyzing that data? Questions like that. And there was also post-lab discussions that had similar content. Additionally, we also did warm-up activities often that specifically were designed to improve students' practices. So one example is this questioning activity where I would put an image up on the board and then students would go around the room and ask as many questions as they possibly could about this image. This was not content linked at all. It was just designed to have students asking questions and working on their practices. In this case, the practice of asking questions, and students were made aware of this goal. Lastly, I gave assessments and then provided feedback that was specifically practice-based in addition to being content-based. So this was assessed qualitatively and quantitatively, and after collecting this data, both qualitative and quantitative, I separated it by positive and negative displays of self-efficacy, and also according to the first category, which was willingness to engage in practices, and then the second category, which was content application of those results. And then for self-efficacy data, I provided scores based on agreement, both a raw score and a percentage score, and then these data were graphed. And then qualitative data was used to support quantitative data by providing good examples of what I was seeing in class. So for my results, I found that number one, students identified science practices as important components of their learning, indicating high self-efficacy and student engagement in science practices. So often students were able to report back what they were learning in class discussion or in reflections or in images. And then students were also more likely to say that practices were the most important concepts that they've learned so far, or embody their first term in science class, even if not specifically directed to describe the most important practices that they've learned so far. Even if I just asked for the most important concept, they often went to data collection or observations or labs or some specific practice that they were using. Additionally, students were able to distinguish between the skills necessary for a scientist versus necessary for a science student, which indicated some metacognition about the differences between those two roles. Second, students showed enthusiasm for increased class time spent on lab investigations. Students often dove into using practices, even if not specifically addressed to do so, and often described these experiences as being fun. Lastly, students were unable to consistently transfer findings from lab investigations to written assessments, which indicated low self-efficacy still in students' content application. So in my teaching journal, I recorded examples of positive and negative self-efficacy in this category, and this didn't change too much over the course of my data collection. Towards the end of my data collection, actually, there were more negative examples in the pink data points than positive examples. There are some exceptions to this. Number one is that students were 50% less likely this year to say that they learned best from in-class lecture. And number two, they also were able to describe this verbally, even if they were often not as confident putting it on paper in an assessment form. So this led me to some additional questions as I began to realize that students needed additional content-based supports in addition to their practice-based supports to connect their findings to content. So I began to incorporate those in labs over the course of the year. And I also wanted to explore this a bit more, so I gave 3 different versions of the same quiz, one that was independent, one that was scaffolded, and one that was guided. And on the self-efficacy survey at the end of those quizzes, students who took the independent and scaffolded versions were much more likely to agree with the statement that I'm a better scientist than I was at this time last year. These students who took the independent and scaffolded versions were also more likely, however, to agree that they are anxious during science tests and quizzes. So this led me to some questions about the role of assessment in inquiry teaching. And if I'm going to teach non-traditionally, what is the purpose and what is the benefit and what are the drawbacks of assessing traditionally? And then at what point does anxiety around tests and quizzes become counterproductive to learning? So in summary, students seemed, number one, better able to identify their own learning of science practices, number two, more willing to use them in investigations, and number three, not consistently able still to view the results of these investigations as legitimate results or potential answers on assessments. And then some questions for future considerations are that what are other content scaffolds that are needed to make students more confident in their investigative power? And then number two, what's the role of assessment in all of this and how can that look different to make this experience better for students? Thank you for listening to my inquiry project, and thank you for everyone who helped to complete it.